All right, so this video will be the exam review for our first test. Um, First, I'll go over the format of the test, what to expect. Basically, my exams are all calculation style questions. That means I don't have any true false, multiple choice, essay, anything like that. No definitions. It's purely given a set of problems, can you solve the problems? So in essence, the test is going to look just like homework assignments. You'll be given some number of questions. Each one it may have multiple parts, may not have multiple parts. But it's a question that'll look just like a practice problem question, and you solve it. You get partial credit, even if you get maybe the answer is wrong, but you did most of the work correct. It's just maybe you typed something in the calculator wrong or you made a little algebraic mistake. I do give partial credit. So it's important then to show your work. Now, this is true also for homework problems, but I've been kind of lax on homework problems. What I've done for those is if the answer is right, then I accept it. But if the answer is wrong, obviously I have no way to give partial credit, so you get the whole thing wrong. On an exam, I will not be that lenient. If you do not show any work and all you have are solutions, just the answer, you get no credit. And that's because I have to be able to tell from your work, from what you turn into me, that you did this work, you answered the question, and you did not, message somebody, look something up online or anything like that. So, you must show your work. If you do not show work and you just have a correct answer sitting there boxed, you get 0 credit for that. However, like I said, I am giving partial credit. So if you have a wrong answer, but most of your work is correct, I give you a good amount of points because to me, most of what it is I'm testing is your ability to think through a problem. Can you read the problem, understand what it's asking, and do you know how to go about solving it? We all make mistakes sometimes and type it in a calculator. Of course, it's important to get things right. However, it's not all or nothing. You can get partial credit for these problems. What's the best way to study? The best way to study, that is to work out the practice problems that are posted on Canvas. For all the topics, I've been posting practice problems and the solutions so that you could work them out. If you're having trouble, you could look at how I would solve it. I have, full written out solutions for each problem. You're able to check to see if you got the right answer. If you're stuck somewhere, you're able to check what the next step would be, things like this. I made those problems. I came up with them. I didn't take them out of a textbook or anything like that. So obviously, the way my mind works in coming up with questions is what those practice problems are. And thus, since I'm making this exam, the same is going to hold true. So obviously the questions I would make up for an exam are going to look very similar to the questions I made for the practice problems because I made them both. It's the same person making the questions. Now, it's important to know that I can give a problem on one of these topics even if I didn't give that exact problem on the homework or on a practice problem. Okay, so you're responsible for questions that are new. Okay, so I'm not going to say if you're going to get the first test and it's guaranteed that every single question on this test, there's an exact example of that on the practice problems. Well, no, I can't do that. There's a huge variety of questions I'm allowed to ask for all of these topics. These topics are very, very general, wide-ranging topics. So you might get a question that you haven't seen in the practice problems. However, that does not mean I can give you a question that you have no idea how to solve. Obviously, it makes no sense for me to give you a question where you don't have the tools necessary or the information necessary to be able to solve the question. It's unfair, and what do I care? Why would I want to make my life miserable having to grade a bunch of problems that I know are going to be wrong because no one knows how to solve them? What must be true is that if I give you a question that you haven't seen before, it has to be very, very closely related to the stuff we've already done. So, for instance, I've given problems on a ramp with a block on a ramp like this, and I've said, okay, here's an example. 30 degrees, and you put a force here, and you say, okay, find the acceleration. Well, of course, I could give a different question where the force is this way. Or I could give a different question where the force is this way. We maybe didn't have these exact examples on the practice problems, but you've seen things similar. And so the thing which makes it new, you'll be able to handle. I'm not going to give you a question where it's like, well, we never even talked about this topic. We never even talked about this material. Obviously, I'm not going to do that. Every question is based on what we've gone over either in the video lectures or the practice problems I've posted or the homework problems I've posted. They're all related very strongly. But I just have to say, technically speaking, you could see a problem that doesn't have an exact representative on one of the practice problems. But I guarantee you, it's related to the practice problems, and it's solved the same way. It's just maybe the picture is different, or maybe the story is different. But it's still a kinematics problem, or it's still a Newton's law problem, or something like that. All right. What do you need to have with you to do the test? Well, I think the way we'll handle the test, being that this is an online class, I have multiple options of how I want to do it. One way we can do it is I set up a online quiz on Canvas, which means you log in. When you log into the quiz, which will be our exam, the timer starts and you're forced to take the quiz right then and there. You can't pause it. You can't leave and come back. You have to finish it once you start it. That's one way of doing it. Another way would be with some of these kind of third-party softwares that allow people to proctor, to watch you solve problems, to make sure you're not cheating, you're not looking online or calling your friend or whatever. But that costs money. The third is to do the test similar to how the homework assignments are done, which is I upload the test at some time, and I give so many hours in the day for you to download, print out the test, solve the test on a separate sheet of paper or on the test itself, however you want to do it, and then you scan it back onto the computer and you upload it back to Canvas. Okay, there's a lot more options for a student who is not being very responsible or honorable to cheat, to communicate with others, to find out what the answers are and all of that stuff. And so it's kind of a dangerous thing. What I've decided is to do the third option. And the reason I'm doing it is because for most of you, this is maybe the first time you've taken a class with me, so you've not seen what my tests are like. And for most of you, this is your first physics course. Maybe you didn't take a physics course in high school or any of that. And so this isn't exactly the most straightforward, easy class in the world. And so I want to make this test comfortable to take and allow you to focus as much as you need to on answering the questions without worries of, will the internet go out, or will my computer restart in the middle of me taking a test, or all sorts of different technical problems that could come up. So that's what we're going to do. Friday morning, I will post, the exam will be posted on Canvas, a new module called Exams. You download the test, you can print it out, however you want to handle it, and you work the test out yourself, either on the test paper, or if you'd rather just do it on a separate sheet of paper, that's fine as well. Answer the questions, show your full work. You box your answers, definitely. Box answers. And you write as neatly and organized as you can. Take your time, because I have to be able to read this stuff to give you credit. Once you're done, you will, as you've been doing for the homework, scan it back into the computer. You make a file with the scan, a PDF file or however, so that, all the pages are in one file. It makes it easier. And then you go back to Canvas and you push the little submission thing and you submit it to Canvas. And then I'll be able to download it and do the grading. So basically, all of this is to say the format of the exam will be the same as the format of the homework assignments have been. You go on Canvas, click on the exam, it'll come up with a PDF file, you print it out, work it all out, scan it back in, submit it back to the page on Canvas. As I said, things you might need for it, have your calculator. And make sure the calculator is in degree mode. I've had some of the homework problems. People got some questions slightly wrong because they use radian mode instead of degree mode. So be very careful you're in degree mode. And the formula sheet. Formula sheet has all the equations you will need to solve these problems. Now, obviously, we're on the honor system. I'm not on your computer. I'm not looking through your webcam to make sure that you're not going online and looking for answers. I want this to be an honest exam. I'm giving you honest questions that are related to things we've done before. And so I'm asking that you take the exam honestly, work it out to the best of your ability, and show what you know. Number one, it helps me gauge how well the video lectures are working in your ability to understand the material. Do I need to give more example problems out, things like this? If everybody makes 100 because everybody cheats, well, then I don't know if, the class is necessarily having problems with what's going on or anything like that. So make an honest effort. Do your own work. Don't text anybody for answers or anything like that. First of all, you never know if the person you're asking for answers also doesn't know the correct answers. And now you just copied off of someone who's got it wrong. That happens way more often than you would think as a professor. So be honest with it. Take the test yourself. Do the best you can. And we'll see how it goes. What are the topics? The topics that are going to be on this particular exam. Well, let's see, what have we gone over? We had a math review from the beginning, which talked about algebra and trigonometry and vectors. I'm not going to have any specific questions that are purely mathematical review. Obviously, all of the actual physics problems we have test your ability to do the math. The math review was just to get you up to speed, to warm your mind up, to remember some of the old stuff, maybe you haven't used it in a while. So I don't have to test, can you solve an algebra equation? Because when I test how to solve this particular physics problem, you're doing the algebra to do it. So don't expect any questions on just math. They're all going to be physics. So obviously the first topic we had was kinematics. So what do we have for kinematics? We had things where we had one-dimensional kinematics and two-dimensional kinematics. One-dimensional, car accelerates, for 8 seconds. How far did it go? Questions like this. The equations we had, x equals v naught t plus 1/2 at squared. We had vf squared is v naught squared plus 2ax. And acceleration is final minus initial velocity over time. Those were our three big equations for kinematics. Two-dimensional, you had the cannonball problem. You shoot a cannonball at a certain angle, find the maximum height, find the time of flight, what's the range of the cannonball. Or a person is standing on the top of a cliff and throws a ball horizontally with an initial velocity. How far from the cliff will the ball land? How long will it take for the ball to land? These types of questions were the kinematics problems. And we certainly had plenty of examples and practice problems on Canvas about it, and we had a homework assignment. So we've gotten some good practice with it. The next topic was Newton's laws. And with Newton's laws, we had a few things. We had, first of all, normal F equals ma type problems. A block is sitting on a table. These forces are acting on the block. Find the acceleration. We also had inclined plane, which is the same type of problem, but now instead of looking in x and y, you're looking in parallel and perpendicular. We had examples of elevator problem. You're in an elevator, standing on a weight scale. If the elevator moves a certain way, what's your apparent weight? How heavy do you feel? That was calculating the normal force. We had pulleys. You have, a pulley. Here's a block. Here's a block. Find the acceleration and the tension for the system. We had Newton's third law. That was, you had multiple blocks connected by a rope. You pull on the rope with a certain force, and you want to know what's the tension in the rope between the block. The third law style of problems. And then, of course, we had friction, which was the last video we had, which basically took all of these problems and you just add friction to them. So you're going to solve all those problems the same way. It's just, how does friction get incorporated? And we found friction is just one extra force. We have to find out which way will friction move or point, but that's easy. Friction always points in a direction opposite to the motion. So you look at the problem, which way will my block move? Friction points the other way. Once you know that, then you know how to incorporate the friction. Usually, though, you don't know how big friction is, so you calculate it. And that gives rise to the second of the formulas. Frictional force is mu times normal force. And so now we have the two equations required for Newton's laws. And these are the two big topics. You can expect half and half. Half the test will be kinematics, half the test will be Newton's laws. I haven't decided how many questions. What I can say is this. In a normal class where you have 1 hour to take the test, I would usually have 5 to 6 problems on the test. That's for a 1 hour test. If I'm giving this test now online as a take-home test, where I would give some number of hours to make sure you definitely have the time to take it, you're not in class, things like this, I can probably give a few more than the 5 or 6 questions, but I'm not going to give you 20 questions or something like this. So expect something between 5 to 10 questions. As I said, I haven't really decided how many. As I'm making the test and I'm seeing which questions I'm adding, if I feel I've added a good range that kind of encompasses everything and I'm only at 6 questions, then there you go, I'll stop at 6. If I feel I better put another one that involves this particular topic, then it might go to 7 or 8 or something. But just so you have kind of an idea, somewhere between 5 and 10 questions on these two big topics. So that's what you can expect for this test. Let me go ahead and just do a couple of examples just to kind of remind you of the things we've been doing. And by the way, you should be of the mindset that by the time it's time to take this test, you should be able to do what I'm about to do. You should be able to explain to somebody or describe to somebody or to yourself, as if you're given a lecture, how to solve these problems. So for instance, say I have a kinematics problem. And let's say I want to solve the problem of I'm on a cliff. The cliff is 20 meters high. I have a rock. The rock is thrown straight to the right with an initial velocity of 10 meters per second. What's going to happen? Obviously, the rock is going to go and land over here somewhere. I'd like to find out what is the range, that is, how far from the cliff will the rock land? And I'd also like to find out the time of flight. Okay, so two things, time of flight and the range. How do I solve this type of problem? Well, first of all, this is a two-dimensional kinematics problem, which means X and Y stuff are going to be important here, and I have to do them separately. What am I given? If I want to go the formal way, let's say I know the initial velocity in the X direction is 10. The initial velocity in the Y direction is 0. The acceleration in the X direction is 0. There's no wind or anything. The acceleration in the Y direction is negative 9.8. Gravity pulling me down. Let's see, the X directional distance, how far does my rock go? I don't know, but that's something I want. The Y directional distance, how far will the rock go in the Y direction? Obviously, it's going to fall from the top of the cliff down to the ground, so it's going to go negative 20 meters, downwards 20. And lastly, the time. I don't know, but that's also what I want to find out. So from my question, this is all the data I know about the system. And personally, I've split it up into X and Y stuff because I know I'm going to have X and Y stuff separate. And now I can start thinking about the problem. Let's try to take time of flight first. I want to calculate time of flight. What are my equations? Well, I've got x equals v naught t plus 1/2 at squared. Vf squared is v naught squared plus 2ax. And acceleration is final minus initial over time. So I need to find an equation that has time. The first equation has time. Okay, can I calculate it in the x direction? Well, let's see. I'd need the x acceleration. I have it, it's 0. I need the x initial velocity, that's 10. And I need the x distance. I don't know that. So no, I can't do it in the x direction. Can I do it in the y direction? I need the y acceleration. I know that, that's gravity. I need the y initial velocity, that's 0. And I need the y distance. I know that, that's negative 20. Perfect, I know everything I need. So I'm going to look in the y direction, and I'm going to use the equation x equals v naught t plus 1/2 at squared. Now I plug my numbers in. Negative 20 equals 0 plus 1/2, negative 9.8 t squared. All right, I want to get t by itself, so the 1/2 negative 9.8, I'm going to divide over to the other side, so I get negative 20 over negative 4.9 is t squared. Take the square root, and I get t equals 2.02. So I now know time of flight. Second part, I want to calculate the range. So that is, I want a distance. In fact, I want an x distance. So again, we look at our equations. First equation has an x distance in it. Can I use it? Well, let's see. I need t. I've got t. I just calculated it. I need the x acceleration. That's 0. I have that. I need the x velocity initial. I have that. That's 10. So I've got everything I need. So looking in the x direction, I use the equation. X equals v naught t plus 1/2 at squared. So v naught in the x direction is 10 times t to 2.02 plus 1/2. A in the x direction is 0 times t squared, but that's just 0, so that doesn't count. So what do I get? I get 20.2 meters. So I now know how far away the rock will land. And that's how I solve this problem. So obviously I'm comfortable with the problem. I've practiced a whole lot, so I remember how to solve a problem like this. If the initial velocity were purely vertical, so I threw the ball upwards or I threw it downwards, then I'd go about solving it the same way, even though it's a slightly different story. The difference being my initial velocity would be a y velocity, and the x one would be 0. But I'd still go through the process. I'd list everything I know, everything I'm looking for. I have the equations sitting there for me to use, and then I look at which equation allows me to solve this thing. Once I know the equation, I say, can I do it in this direction, x? If not, can I do it in this direction, y? If so, you do it. If not, move on to another equation. So that's kinematic style problems. What about Newton's law type problem? Well, let's take one. I didn't do too many of these, so let's do another one that's kind of got a vertical wall instead of a horizontal. We did a whole bunch of horizontal ones. Here's a block whose mass is 10. I'm going to push on the block with a force of 100. And let's say there's some friction, just to make it even harder. Mu equals 0.2. What do I know? I know that this force is applied at an angle of 30 degrees like this. I'd like to find out the acceleration of the block. I could also say, find the normal force. I know I'm going to need it for finding friction, but I can ask it as a separate question if I want. All right, so let's do this. Let's look at our problem. Here I have a block on a vertical wall. Force is sitting there at an angle. I would ask the question, what's the major correct directions that are going to be important? Well, if the wall is a vertical wall, then obviously the block's going to slide up and down. So the major directions that are important are the X and Y directions. The reason I mention it is because that tells me every force that I'm going to have in my problem better be an X and a Y force. I don't want any angled forces here. So the first thing I would do is I would take this applied force F and I'd break it up into an X and a Y component. So we do it. We look at this, make a little triangle out of him. Here's the Y side, here's the X side. The X piece is the piece adjacent to the angle. That means cosine, so it's 100 cosine of 30. Positive or negative, the force is being applied up and to the right. To the right makes him positive. So 100 cosine 30, that's 86.6. What about the Y component? Well, the Y side is the side opposite, so that's sine. 100 sine 30. Is that positive or negative? Again, the force is up and to the right. In the Y direction, it's up. So he's positive. So we have 50. Are there any other forces in this problem? Sure. There's also gravity. Gravity is always pointing down. And there's also a normal force. Which way will the normal force point? Well, remember what normal means. Normal means perpendicular. So the normal force should point perpendicular to the surface. Here the surface is a vertical surface. Perpendicular means it's going to point horizontally. Well, does that mean it points to the left or to the right? Well, look at the problem. I'm trying to push my block up and to the right. My block's not going to flow through the wall. So the wall has to push back. Thus, the normal force has to push to the left, like this. And then, of course, there's going to be friction. I don't yet know the direction of friction. Can you tell? Well, let's see. Friction wants to oppose motion. So first figure out which way will the block slide if there is no friction. Well, let's see. Block wants to move up and down, so I'm looking at Y stuff. The force that I push upwards is 50 in the Y direction, so there's 50 going up. How much is going down? mg. The force of gravity in the Y direction is mg, which is 10, in this case, 10 times 9.8, which is 98. And that's pointing downwards, negative. So that means on this block, looking only in the Y direction, there's 50 newtons pushing him up, and there's 98 newtons pulling him down. Obviously, the 98 wins, so this block wants to move downwards. Because he moves down, friction must point up. So friction is pointing upwards. All right, so I've analyzed the system as much as I can analyze it. Now we want to solve our two problems. Let's look at the normal force first. Solving for normal force. How am I going to do it? Look at your picture with all the forces. Which way does normal force point? X direction. So I'm going to look in the X direction and I'm going to say sum of the forces equals MA in that direction. What do we have? Normal force is to the left, so he's minus normal force. Do we have any other x forces? Yep, the x component of my f, which is 86.6 to the right, so plus 86.6. And those are the only two x forces in this problem, so I set it equal to ma. But I know my block will not move in the x direction. It's only moving up and down. So that is just 0. So here's my equation. Solve for n. N must be 86.6 newtons. I now know the normal force. Done. Now we want to find acceleration. How do I do that? Well, I asked the question, which direction is the acceleration? Up and down. So I'm going to look in the y direction. What's my equation? Sum of the forces in the y direction equals ma. Plug in all my y forces. Let's see, I've got mg pointing down, so minus 10 times 9.8. I've got the amount of my applied force, my pushing, going up, so plus 50. And then I also have frictional force pointing up, so plus frictional force. And those are the only three y forces here. So set that equal to m times a. Now I'd like to solve this for a, but I can't because there's this unknown force of friction sitting here. So I go off to the side and I say, let's calculate friction. Frictional force is mu times normal force. What's mu in this problem? 0.2. What's normal force? Well, I just calculated it in part A, 86.6. So I get my calculator out, I do 0.2 times 86.6, and I get 17.32. Now I know frictional force. So I go back here, I have minus 98 plus 50 plus 17.32 equals 10 times A. So I get my calculator, minus 98 plus 50 plus 17.32. All of that divided by 10 tells me my acceleration is negative 3.07. Why is it negative? Because the block is moving down. And there you go. A nice, perfect, frictional force, Newton's law type problem. We had to worry about normal force, which is a very important topic. We had to be able to draw a free body diagram. What are all the forces? We had to do components. We had to calculate friction over here. And then normal Newton's second law, F equals ma type thing. So a very nice problem to practice because you have to practice a whole lot of different things. Each thing by itself is easy. You can see all of these formulas are little 3 variable formulas. They're very small. The algebra involved is not all that complicated. All that's necessary is for you to remember, when I get a problem that looks like this, these are the questions I ask myself. And when I ask myself this question, I solve that question. I give myself the answer. I do it either by doing components or by intuition. Which direction will the block move? Well, picture the system. Obviously, the block's not going to move left and right. That would be weird. The block has to move up and down in this system. So the acceleration has to be in the y direction. How did I know the normal force is in the x direction? Well, because the normal force is always perpendicular to the surface. Here, the surface is a y surface. It's vertical. So, of course, normal force had to be horizontal. Why is it to the left instead of the right? Well, because as I push my block into the wall pushes back. So the wall's pushing to the left. So you can see, You should be able, after you're done working your way through practice problems, you should be able to sit down with a blank sheet of paper and talk your way through this stuff. Even if you don't necessarily do all the calculations, you should be able to have a friend sitting next to you and tell them the steps, explain to them how to solve the problem. If you can explain how to solve the problem, then you'll definitely be able to solve the problem. So if you're not at that point yet, you need to keep practicing these problems, looking at the solutions I've posted, looking at the videos I've posted, and think about the thought process I'm trying to give as I solve these out. Furthermore, there's nothing stopping you from going on YouTube or other places and watching other people's videos. There's lots and lots of posted videos either from other universities or just people who are doing it just because they want to help, where they show you how they solve problems. They may have a slightly different way of thinking about things than I do, and that's fine, as long as what you're doing is legal, it's, mathematically correct. Whatever clicks with you is the way you want to go about doing it. I'm giving what I have found to be, at least in my mind, the most intuitive ways of thinking about things, and also what has helped the most students when they ask how to think about these problems. But not everybody's the same. And so if you need more help than what you're getting from my videos or my practice problems, go on YouTube and search how to solve Newton's second law problem, or how to solve inclined plane problem, or a pulley problem, or whatever. And you'll find lots and lots of examples written out there for you. But definitely what you want is by Friday, you should have a blank sheet of paper in front of you. You'll look at the practice problems I've posted, and you should be able to work it beginning to end without having to look at the solutions. If you could get to that point, this exam is going to be a cinch, I promise you. So that's all I have for this exam review. As I said, Friday will be the test. I'm going to post it on Canvas, and I'm going to give some amount of time, and I'll be more specific about that when I send the email to let you know it's posted. But I'll give you the day in case you have classes in the daytime to be able to work on it. It's going to be the same kind of way you've been doing the homework assignments. You need your calculator and a formula sheet, and the two big topics, obviously, are what we've done. Kinematics, one-dimensional and two-dimensional, and Newton's law problems, which is friction, Newton's third law, pulleys, elevators, inclined planes, things like that. So, good luck. Practice as many problems as you can. If you're having trouble or you have some questions for me, feel free to email me, and I'll do my best to help you along the way. See you later.